Hello and welcome. This is Math Affair, and we're going to be rationalizing the denominator today. Let's get right into it. What is rationalizing the denominator? In math, rationalizing the denominator is the process of removing surds from the denominator and moving them to the numerator. All right, so let's say I have 2 divided by square root of 3. Now, we do not want to write fractions with roots in the denominator. This we do not want. So to correct this, or to write this in a better format, we are going to rationalize the denominator, meaning we want the denominator to become a whole number. What we want is the denominator to become a whole number. And remember, whole numbers are what? Rational. A whole number is rational. If you're not sure about all of this terminology, you can watch my video where I talked about the number system, rational numbers, and irrational numbers. All right, so this is the process of removing surds from the denominator and moving them away to the numerator. And the result of that is we are going to have just whole numbers in the denominator, and denominators are rational. That is why the process is called rationalizing, meaning we are converting the denominator from an irrational surd to a rational number. So hence the name rationalizing the denominator, converting the denominator to a rational number. That's what rationalizing is all about. All right, the next thing on your mind would be then, how do we get it done? How do we get it done? Now, there are 2 possible situations that you want to keep in mind when it comes to rationalizing the denominator. I'm going to take a look at the first case scenario. Case scenario number 1. If I'm given any numerator divided by square root of b, let's say. Now, if I have just one term in the denominator, all I have is root b in the denominator. There's no other term. Then to rationalize this fraction, I would need to multiply it by square root of b over square root of b. This is going to get our job done. If I multiply the whole fraction by root b over root b, I'm going to be able to rationalize. Now, keep in mind, root b divided by root b essentially is equivalent to 1. So really, what I'm doing is multiplying a over root b by 1. So it means we're not changing the value of root b. Sorry, we're not changing the value of a over root b. So keep that in mind. But this is going to get our job done. So to multiply, when you're multiplying fractions, remember you multiply the numerator by the numerator, the denominator by the denominator. So let's have a go at it. Multiplying the numerators, I have a multiplied by root b, which returns a root b, okay, over. In the denominator, root b multiplied by root b is just a whole number b. This, again, is one of our rules or laws when it comes to surds. When you multiply a root by itself twice, the roots cancel and we just have the number b in this case. So we have successfully removed the root from the denominator. Take a look at how we started. We started with a over root b. We had a root in the denominator. Now, all I have now is just a b. So the denominator no longer has any roots, no more surds. But then that surd, we now have it appearing in the numerator, and that's pretty fine. We can have fractions with roots in the numerator, but not in the denominator. So this is your first case scenario. This is the first case. Let's take a look at an example which goes along with this particular case. So let's say, for example, I am given 2 divided by square root of 5. And I want to rationalize. We have a root in the denominator, so we are going to have to rationalize. And we say to rationalize, you're going to multiply the entire fraction, both the numerator and denominator, by that same root in the denominator. So we're going to multiply by root 5, multiply by root 5. And carrying out our multiplication, we have 2 multiplied by root 5, which is 2 root 5. Root 5 in the denominator multiplied by root 5 would return just an ordinary number 5. And if at all we can simplify our answer, the last step would be to simplify your solution. In our example, what we have right now really cannot be simplified. Don't be tempted to cancel out. Don't be tempted to cancel out the root 5 and the 5. Remember, this is not a 5. This is square root of 5. It's a totally different number from the root 5. So in this case, we cannot cancel out. Neither does 2 divide by 5 to any simpler form. So this is our solution. But maybe let's take something that can be simplified in the end. So another example right here. We have 6 divided by the square root of 2. Right, so we are going to begin our process of rationalizing, and remember, to get that done means we're going to multiply the numerator by root 2 as well as the denominator by root 2. Okay, carrying out the process of multiplication, numerator by numerator, 6 multiplied by root 2 is 6 root 2. Well, in the denominator, root 2 multiplied by root 2 returns a whole number 2. And now to simplify my solution, if possible, and in this case, it is possible, I'm going to divide the whole numbers. So the 6 will divide by 2 naturally, and that gives us a whole number 3. And of course, our root remains there. So 3 root 2 would be our final solution. All right, so this is the first case scenario where you have a single root in the denominator, and that's how we rationalize. Okay, moving on to the second case. Let's say you have something like this. We could have anything in the numerator, right? A there is just representing any number, and it could be any number, a zebra, a mouse, a cat, anything in the numerator. We don't care about the numerator. But let's say your denominator has 2 terms where both terms could be surds or one of them is a surd. So I'm talking about a situation like this or a situation like that, where we have root B plus root C. So this is our second case scenario, okay, where we have anything in the numerator really, but our denominators have 2 terms. In the denominator, we strictly have 2 terms. And in those 2 terms, both of them could be surds, or maybe just one of them is a surd. So we could say at least one of the terms in the denominator is a surd. In this case, to rationalize the denominator, you're going to multiply by the opposite of the denominator. So I'm going to put this in writing. You're going to multiply by the opposite of the denominator. Now, what do we mean by the opposite? What do we mean by this word opposite right here? The opposite of the denominator is taking the same denominator and changing the sign. So for example, if I have root 2 minus 1, the opposite of root 2 minus 1 would be root 2 plus 1. You do not change the signs of each term in the expression. No, you simply change the sign in the middle. So right here, I started out with a negative, and then the opposite would have a plus. Similarly, if I start up with a root 5 plus a root 3, and I want the opposite of this particular expression. The opposite would simply the same terms. I would take the same terms, but change the sign in between them. So these are binomial expressions. They have two terms, and the opposite is simply flipping the sign between the terms. This is what we mean by the opposite. All right, so now that we know what the opposite is, let's go right away into how then to rationalize by multiplying with the opposite. Let's see this in action. So I'm going to start up with any one of these cases. Let's take the first case where we just have one root in the denominator. Okay, so if I start up with the square root of, okay, so I have a divided by the square root of b plus c. And I said to rationalize this, we're going to multiply by root of b minus c. Okay, the same thing in the denominator, you multiply by exactly the same thing. So effectively, we are still multiplying by 1. This is equivalent to 1 because it's the same number divided by the same number. So I am not changing the expression we started with. But we're going to get our job done. We are going to be able to rationalize the denominator. Remember the objective. We do not want any roots in the denominator. And this is how to get it done. So just follow through and see me multiplying here, and let's take a look at how things will go. So as usual, when you're multiplying a fraction in the fraction, the numerator multiplies with the numerator, the denominator multiplies with the denominator. But now because we have more than one term in the denominator, we have terms multiplying with other terms, you might want to place some brackets for your multiplication. So I'm going to write it like that. I'm going to have some brackets right there, some brackets right there, and some brackets right there. So when I multiply in the numerator, this is going to be a multiplied by root b. That's going to be a root b minus a multiplied by c is going to be ac. All divided by, in the denominator, we're going to do exactly the same thing using our law of expansion. So I'm going to multiply root b multiplied by root b, which returns a whole number b. Then root b multiplied by negative c is a negative c root b. Moving on to c, c multiplied by root b is c root b. And finally, a whole number c multiplied by a negative c would just return a negative c squared. Now it's time to simplify. It's time to simplify, and if I'm going to simplify the numerator, we're going to keep it as it is, but in the denominator, I'm going to collect like terms. So I have a root b minus ac whole divided by a b. Now take a close look at these two terms here. These are like terms. We're going to collect them. So that's a negative c root b plus c root b, which is equivalent to 0. So these two terms here would cancel out. And all I have remaining is my b minus my c squared. Now, depending on what the values of b and c are, but b and c are obviously going to be whole numbers in this case. So we no longer have any roots in the denominator. Like I said, we can have roots in the numerator, but not in the denominator. So we don't see any signs or any trace of surds or roots in the denominator. Now let's put some numbers to this. Let's take an example with numbers, with numerals. Okay. So my first example with you looks like this. Let's say we are given a whole number 2 right here, being divided by 1 plus root 3. Okay, so to get our job done, to rationalize, we're going to multiply this by the opposite of the denominator. And keep in mind, you multiply both the numerator and the denominator every time. So I'm going to multiply by 1 minus root 3 in the numerator, and as well multiply by 1 minus root 3 in the denominator. And as I said earlier on, would like to use some brackets here. Okay, we begin our multiplication, and in the numerator, you really don't have to expand in case we can simplify. So we could keep this as 2 multiplied by 1 minus root 3. just in case, we'll be able to simplify at the end. You could keep your numerator in brackets this way. But in the denominator, we are going to expand, of course. So 1 multiplied by 1 is a whole number 1. 1 multiplied by negative root 3, we have a negative root 3 right there. A root 3 times 1 is a positive root 3. And finally, root 3 times negative root 3 is a negative whole number 3. And as we're expecting, our two middle terms in the denominator are going to cancel out. Minus root 3 plus root 3 is essentially 0, so we can get rid of them. And simplifying this, we have 2 multiplied by 1 minus root 3, whole divided by 1 minus 3 in the denominator. Now, 1 minus 3 would essentially return a negative 2. And like I said, if we can simplify our solutions, we always want to make sure we give our answers in the simplest form. And when you go through most of the exam questions, you're going to find that the examiner wants us to simplify our answers. They always push us in that direction to give our answers in the simplest form. So I'm going to divide our 2 divided by negative 2. That's a negative 1. So I have a negative 1 remaining. And then I still have my bracket 1 minus root 3. Which, if I want to, we could expand this and write our solution as a negative 1 plus root 3. Or you could write it as root 3 minus 1. It's exactly the same. So this is the process of rationalizing the denominator. Now, the same concept would apply even for our other situation where we have both terms being roots. So we'll take one more example to that effect, just to make sure you see that it's exactly the same. There's no difference. All right, so just one more example coming up. So let's say we are given a 2 plus a root 3, and the whole expression is being divided by a root 5 minus a root 3. Okay, so this is exactly the same thing. We're not going to change the method. We said whether you have one of the terms in the denominator having a root or both of them are roots, both of them are surds. You are simply going to do exactly the same thing, multiply by the opposite. So me multiplying by the opposite, take a look. This is root 5 plus root 3. Same thing in the denominator, we are going to multiply by a root 5 plus a root 3. All right, so I like to put brackets around everything, have that good feeling of expansion. All right, so let's begin. This is going to be a whole lot of work. All right, so starting up with the numerator and the numerator, let's expand. Okay, so we are going to have 2 multiplied by root 5 is a 2 root 5. 2 multiplied by root 3 is a 2 root 3. Okay, then I have a root 3 multiplied by a root 5. That's going to be a root 15. Okay, and finally, the last term, root 3 multiplied by root 3 is just a whole number 3. Then we move on into the denominator. Let's expand. Root 5 multiplied by root 5 returns a whole number 5. A root 5 multiplied by a root 3 is a root 15, positive root 15. A negative root 3 and a positive root 5 is a negative root 15. And finally, the last term, a negative root 3 and a positive root 3 would return a negative 3. All right, so this is what we have after expanding. You want to make sure you take your time to do the expansion. We don't want to get any one of our terms wrong. So take your time on the expansion. Do your expansion very carefully. Double check your work. All right, so simplifying the numerator, we don't have any like terms in the numerator, so we're going to keep our numerator this way. But in the denominator, we can definitely simplify by collecting like terms. So the root 15 minus root 15 is essentially 0. Okay, and the 5 minus 3 there would return a whole number 2. So writing or presenting our answer in the simplest form, we still have the same numerator, 2 root 5, plus a 2 root 3, plus root 15, plus a whole number 3, whole divided by a whole number 2 in the denominator. We have just achieved our objective. No more surds in the denominator, no trace of any roots in the denominator, and that's exactly what we wanted.